Effect of the stage compression with intercooling on the Brayton cycle. In this type of cycle, basic elements are two compressor, that means C1 and C2, one turbine T, one combustion chamber. So this is combustion chamber, condenser, intercooler, now in TS diagram and PV diagram, this is TS and this is PV diagram. I'll show the three different pressure line within which this cycle will operate. This color is condenser pressure, this one is intercooler pressure, and this red color is combustion chamber pressure. That has been used in PV diagram also. Now we will start from the first compressor. That means before first compressor, suppose 1. Suppose this point is in TS diagram here 1. Now 1 to 2 process is reversible adiabatic compression process where we have to invest some work. That can be shown in the TS diagram. Reversible adiabatic means isentropic, that means 1 to 2 process. This is 1 to 2 process. In PV diagram, that is PV diagram, also we can show the process. This is, suppose this is 1 and suppose this is 2. So this is 1 to 2 process. This is reversible compression process. After reversible compression, the temperature of the working fluid will increase, which has been cooled down in the intercooler section by amount of, suppose, Q2 dash. So 2 to 3 is nothing but the constant pressure heat rejection. So temperature of the working fluid will cool down to the initial temperature. So we can, so there will be the 2 to 3 process. So this is the 2 to 3 process in TS diagram, and this is the 2 to 3 process in PV diagram. So this is compression process where some work we have to invest, and 2 to 3 process is heat rejection process by amount of Q2 dash, and after that again that will pass through the second compressor. This is also a reversible adiabatic process. So 3 to 4 process is reversible adiabatic process. So that will be also in TS diagram here. 3 to 4 process. In here 3 to 4 process will be just like that. A curve will be there. So this is 3 to 4 process is reversible compression process. reversible adiabatic compression process. We have to invest some work here also, WC2. And after that, that will come to the turbine via combustion chamber, where Q1 amount of heat will supply. So 4 to 5 process is heat supplied process at constant pressure. So suppose in TS diagram, this is 4 to 5 process. Suppose here heat supplied by Q, how much? Q1. In PV diagram, suppose this is the 4 to 5 process. Q1 amount of heat will supply. And after that, heat supply that will passing through the turbine section. And this is reversible adiabatic expansion process. After expansion through the turbine, there will be developed some work by turbine. Reversible adiabatic process. So this is reversible adiabatic process 5 to 6. 5 to 6. In PV diagram that will be, but in PV diagram that will be just like that. So 5 to 6 is reversible adiabatic expansion through the turbine, where turbine develop some work, WT. So this is WT. And after that, that will come to again compression on via condenser, where Q2 amount of heat will reject. So this 5 to 6 is the expansion, 6 to 1 is heat rejection at constant pressure in the condenser. So 6 to 1 is heat rejection in the condenser by amount of Q2. Here also 6 to 1. So this is the whole process. Now, so in TS and PV diagram, the cycle is 1, 2 is compression, 2 to 3 is cooling process in the intercooler, 3 to 4 process again compression, 4 to 5 process combustion chamber heat addition, 5 to 6 process is nothing but the reversible adiabatic expansion process in the turbine, where WT amount of work will develop, and after that, that will come to the condenser. This is condenser, this is condenser, where Q2 amount of heat will reject, and again it will send to the compressor. Now concentrate on this TS diagram. If I have to draw the basic cycle without stress compression and intercooling, then the cycle becomes what? The cycle becomes just like that. That means I can say this is 2 dash. Here cycle becomes 2 dash. So the cycle becomes 1, 2 dash, 5, 6, 1. 1, 2 dash, 5, 6, 1. Clear? So this elementary cycle, that means 2, 3, 4, 2 dash 2 will add it with this basic cycle. That means 1, 2 dash, 5, 6, 1. So there is more work capacity since the included area. How much? This one. So for this staged compression with intercooling, more work capacity will be, because included of this elementary cycles area. That means by 2, 3, 4, 2-2. But the heat supply becomes more. Now, for this elementary cycle, if we will concentrate, then the mean temperature of heat addition, that means the heat addition from 4 to 2, mean temperature of heat addition, if I will say this is the mean temperature of heat addition, that means Tm1, and mean temperature of heat rejection, that means 2 to 3, that is mean temperature of heat rejection, suppose Tm2, and this basic cycle mean temperature of heat addition, suppose this one Tm1, and mean temperature of heat rejection for this basic cycle is, suppose here Tm2 dash, this is Tm1. For the basic cycles, mean temperature of heat addition is Tm1 dash, and mean temperature of heat rejection for this basic cycle is Tm2 dash. So for the basic cycle, 1, 2 dash, 5, 6, mean temperature of heat addition is Tm1 dash, and mean temperature of heat rejection is Tm2 dash. For the elementary cycle, 2, 3, 4, 2 dash, mean temperature of heat addition Tm1, and mean temperature of heat addition Tm2. Now from this diagram, it is clear that Tm1 dash is greater than Tm1, but Tm2 dash is less than Tm2. So the efficiency of the cycle, with staged compression and intercooling will be low. But if the regenerator is used, the low temperature heat addition, that means the 4 to 2, between 4 to 2 section heat addition, which can be achieved by the exhaust gas. That means if we will able to heating the gas for the section of 4 to 2 by the exhaust gas, then there may be a net gain of efficiency. When intercooling is adopted in conjunction with a regenerator. Clear? That means if this section heating process can be achieved by the exhaust gas, then the whole process will be profitable in terms of increase of the efficiency for that cycle. So I hope that will help you to understand the effect of a staged compression with intercooling on Brayton cycle, where we use 2 compressor instead of a single compressor to achieve the same pressure ratio. Thank you.